In section 11, we're extending what we did in the previous section, looking at reversing operations, and now we're going to use that process to actually solve equations. So in our warm-up here, we're asked to write the steps necessary to reverse the operations on x. So on number 1, we have 4x plus 11. To reverse this expression, we're going to subtract 11, and then we're going to divide by 4. Again, our process, if we have no parentheses, we want to reverse any addition and subtraction first, and then reverse any multiplication and division. On number 2 and 3, though, we do have parentheses. We want to first start off with whatever is outside of the parentheses, and try to reverse that. On number 2, I'm looking and seeing that there's a 9 out in front of the parentheses, so the first thing I want to do is reverse that. If I have a 9 in front of parentheses, that indicates multiplication, so to reverse it, I'm going to divide by 11, 9. And then now that the parentheses are gone, we're on the inside of the expression. So we have x divided by 2 minus 4. We're going to reverse any addition and subtraction. So I'm going to add 4. And I'm going to multiply by 2. On number 3, a little bit more involved. We have two operations on the outside. Looks like we have a negative 2 multiplication and a plus 1, so an addition and a multiplication. Just like we did with inside the parentheses, we're going to reverse anything that's outside the parentheses, looking for addition and subtraction first. So because I have a plus 1, my first step is going to be to subtract 1. My next step is going to be to get rid of that negative 2 by dividing by negative 2. Then I'm going to subtract 4. Now we're inside the parentheses. And my final step will be to divide by 5. All right, now we're going to revisit that problem in just a minute. But we're going to jump ahead a little bit to activity 2, where we're starting to look at the order of how we're going to reverse that. So notice here in these problems for this activity, we have it's not expressions anymore, now they're equations. So we have an expression on the left-hand side, and then we have a number on the right-hand side. Our ultimate goal is to find out what x is. That's what we're trying to solve for. So to do that, we're going to make sure that we put the correct operations in the correct order to reverse. All these problems here are telling us that these are the steps we need to do, but they may or may not be in the correct order. They're asking us to put them in the correct order. So number 1, we have 3x minus 5 equals 7. To reverse this, I need to reverse the addition or subtraction. So I'm going to have to remove that negative 5 by adding 5. So our first step, let's go purple this time. We're going to add 5 and then divide by 3. And that will reverse our operations. Number 2 is very similar. Number 3, let's take a look at that one. That one has parentheses. So we have 6 times the quantity x minus 4 equals 18. So to reverse that, we're looking for any expressions on the outside. We have that 6. That's got to go first. We divide by 6. And then we're going to add 4. Let's get to a more complicated one. Let's do number 7. That's a good-looking problem there. We got 5 times the quantity x divided by 3 plus 5 minus 5 equals 30. So a lot of 5s going on in this problem. Again, we're looking on the outside of the parentheses. We've got a 5 and out in the front. That indicates multiplication, and that's subtracting 5 right next to the equation. So that indicates, obviously, subtraction. When we have those expressions, the numbers on the outside, first thing we're looking for is to reverse any addition and subtraction. So I'm going to reverse that subtracting 5 by adding 5. So that's my first step. So that's out of here. Then I'm going to get rid of that 5 out in the front because it's currently being multiplied. I'm going to divide by 5. And that'll take care of that. Now we have that expression on the inside. We have an add 5, so we're going to subtract 5 to get rid of that. And then we're going to multiply by 3. Now our goal then is we're going to apply this order of steps to that number 30. So when we actually solve this, we're going to add 5 to it, then we're going to divide by 5, then we're going to subtract 5, and then we're going to multiply by 3, and we would find out what x equals. And that's what we're going to do next. We're going to flip back here to activity number 1. So in activity 1, we have those expressions we had from the warm-up. Now again, we already solved reversed them, subtract 11, divide by 4, and so on. Now what we didn't quite do in this activity is show the kind of the step from here to here, just kind of a little bit of a jump. So we're going to go ahead and write those in. So we have 4x plus 11 equals 31. We're actually going to solve this expression now as an equation. So I'm going to take away 11, and you see that when I do that, plus 11 and then subtract 11, that will cancel out. That's going to reverse that operation. And then 31 minus 11 is going to give me 20. My next step then, according to my warm-up here, is to divide by 4. And this will cancel that 4, but for a different reason. With addition and subtraction, we're canceling out to turn it into a 0. But when we have multiplication and division, we're trying to cancel it out to turn that number in front of x, in this case, into a 1. And when we do that, we get x equals 5. So if we look at the second one, similar type of problem, but a little bit more complicated. We know our first step here is to divide by 9, so I'm going to put a 9 here and here. Now, just to clarify here, that equal sign is going to divide sides up. So this is going to be the left side of the equation and the right. So if we're dividing by 9, we're just dividing one thing on the left and one thing on the right, and ends up canceling some things out. All right, so we're at x over 2 minus 4 equals 4. Our second step says to add 4, so that's a plus 4 and a plus 4. So the negative 4 and the positive 4 will cancel. And I've got x divided by 2 equals 8, because that's 4 plus 4. And then I'm going to multiply by 2. And that cancels, and we get 16. Now, when we're graphing these, and that's the next thing we're going to have to do, if we look down at the problems down below, it says graph your solution on the given number line. Here's our goal. We're just basically going to set up our number line, and we're going to put our solution on it for now. So x equals 5. I'm going to put 5 there, and a closed-in circle. Doesn't make a whole lot of sense why we're doing that yet, but you'll see that later when we get to linear inequalities, that maybe it's just not that one particular number that's a solution, but maybe there's more to it than that. But for now, we want to make sure we know that distinction between a solution of an equation and the solution of an inequality. So we're getting that practice of getting those graphs set up. So we're just going to do a couple problems here just real quick to make sure that we've got the main idea of this. Number 5 looks like an interesting problem, so let's go ahead and do that one. We have x divided by 4 minus 7 equals 9. I don't see any parentheses, so my first thing I'm looking for is, do we have any addition or subtraction that we want to reverse? I'm seeing a minus 7, so I think I want to get rid of that first, plus 7 to reverse it. And again, that equal sign divides the left and the right, and I'm just going to call that L and R. Once we've got that done, let's see, we've got x divided by 4 equals 16. So my next step would be to get rid of any multiplication or division, which I see right here, dividing by 4. So I'm going to multiply by 4, and I get x equals 64. So I graph that as a closed circle. All right, let's look at, let's pick out a good one here. How about number 10? Number 10, we have 4 times quantity x divided by 7 minus 4 plus 3 equals negative 5. First thing I'm looking for, I do have parentheses here. So now I'm looking for things on the outside. And I'm seeing 2 things on the outside. We've got this 4 and this 3. And we want to get rid of both of those before we start dealing with the inside of the parentheses. So it looks like we have multiplication and addition that we need to reverse. So the first thing I'm going to do is reverse this addition of subtracting 3. Then I still have to get rid of that 4, so I'm going to reverse that by dividing by 4. And the nice thing is, once we've done that, the parentheses will be gone now. And then we're going to add 4, because again, parentheses are gone. We're looking for addition and subtraction, so I've got a plus 4. And we have one more step to do. We're going to get rid of or reverse that dividing by 7 by multiplying by 7. So x is 14. So I'm going to graph 14 on my number line. Alright, one more. Let's look at 14. I really like number 14 for the reason that it's got that negative in front of the x, so that's going to make things a little bit interesting for us. The first thing we're going to do, again, look for anything on the outside of the parentheses. I just see that 5, multiplication. So to reverse that, I'm going to divide. Once those parentheses are gone, I'm looking to get rid of addition and subtraction. Now this is not a minus 2x. This is a negative 2 times x. Those are different things altogether. This is multiplication, so we're going to deal with that towards the very end. To get rid of plus 5, I'm going to subtract 5. And that will reverse it. And then, to remove that negative 2, because it's multiplication, I'm going to divide by that. I'm not going to add 2 to both sides. I'm going to divide by negative 2. And when I take 2 divided by negative 2, I get negative 1. Again, put that number on the number line and then graph that. So that gives you kind of a mixed bag of those different types of solving equations by reversing operations. But again, there's limitations to this. It only works when we have the variables on one side, and we'll get later into some examples where we don't have variables on just one side, and what do we do with that. But that is for a different time.